Everyone, today we will be solving LeetCode 547, number of provinces. So let's first see the problem statement. So the problem is saying that we have n cities, and each city that are connected with other cities are counted as a province. So for example, if we have cities connected like this will count as one province. So we return 1 as our answer. If we have another example where we have cities connected like this, then we see that this is one province, and this is another province. So we have 2 as our answer. And then a final example to really drive this point across, if we have cities connected like this, for example, and then we have another city like this, then we see that we have 2 provinces again. This is one province, and this is our second province. So then we will return the answer of 2. So the question is pretty easy to understand. So let's see how we could solve this. Well, the solution to the problem won't be too bad if we know the algorithm of DFS, or depth first search. So DFS. So let's see what DFS, how does DFS work? So if we have a graph like this, if you have a tree like this, how would DFS traverse it? In a general principle, DFS would traverse it like this visually. It will go to its deepest node and then keep on traversing until it finishes traversing the whole entire tree. So it will go down to its deepest node first and keep on traversing the deepest nodes. So how does this work in detail? So let's look at an example. Let's create a stack that we could call the fringe or the frontier, and then let's create a visited set. So let's traverse this graph using DFS. So first we will have A, our starting node, right? And then this will be visited, so then it will be pushed into our visited set, and then we pop from our fringe. And then we could push A's children, B and G, onto our stack, and we could see that B has childs C, D, and E. So then we could when we visit B, we will pop it from the fringe and push it into our visited set, and then we could push B's children onto our fringe, like so. And then we can see C, we go pop C from the fringe and then push it onto our visited array. And then C, since it has no more children, we don't have to worry about it. Then let's look at D. D is visited, so it's put into our visited set, and then has no children, so don't worry about it. And then let's visit E. So after we visit E, we see that A has a children F, so we'll put F into our fringe. And after this, we see that F has no more children, so then we could pop F from our stack and put it in our visited set. And then we look at G finally, and G has no more children, so then we could simply put it into our visited set and pop it from our fringe. So this is the order that DFS would traverse this graph: A, B, C, then D, E, and then F and G. All right, let's see how this works with an example. Let's say we have these cities, A, B, and C connected to each other, and cities D and E connected to each other. So that means we're given the input of cities A, B, C, D, and E. Let me write some pseudocode to motivate how we will solve the solution. So for each city in cities, right, if this city is not in, let me move this over. If the city is not in our visited set, that means we found a province. So we increment our answer by 1, and then we run DFS on the city to find all the connections, and then we return our answer. So this is the crux of the algorithm. I am writing this out in Python since Java is a little verbose, but I'll write the solution in Java. Okay, so let's look at how this works by running through this example. So we have cities A, B, C, D, and E. What this code would do is that you'll first look at the input city A, right? And you'll see city A is not in our visited set because the visited set is empty. So then we will increment our answer to be 1. Okay, that means we found one province. And then we run DFS. Then DFS, as talked about earlier, would find A, B, and C. So you'll find that these cities are connected. All right, so then we look at city B in our input. B is already in our visited set, and this makes sense because this is connected, city B is connected to city A, which we have counted in our answer already. So then we don't increment our answer because we didn't find any province. And then we look at city C, right? City C is clearly connected to city A. It's part of one province, which is shown by being in the visited array. Since we visited the city already, that means we didn't find a new province. And then let's look at city D. When we see city D, right, city D is not in our visited set. Since city D is not in here, that means we found a new province, and our answer is incremented to 2. And we could put D into our visited set by DFS, and DFS traverses, and it finds that E is connected to D, as talked about earlier, about how DFS traversal works. And then we see that our visited set is now populated with A, B, C, D, and E. And then let's look at city E, right? City E is in our visited set already, so then we don't need to visit it again, so we don't need to increment our answer. So we see that our answer is 2. There are 2 provinces. So this is basically the code to solve it, and let's code it up real quick. So first, let's start with our inits. So we want a visited set. So hash set integer, let's call this visited, equals new hash set integer. You can also use a Boolean array and keep track of all the visited cities by its index, but I'm going to use a hash set in this case. Okay, let's have our answer to be 0. Let's create our helper DFS function. So private void DFS, our city that we want, our visited hash set, and our input, which is connected. So how would our DFS work? So for each city, right? So for I equals 0, I is less than is connected. So for all of our cities, let's check if it's a neighbor. So if is connected city I and I equals 1, that means they are neighbors, right? According to the question description, and that it hasn't been in the visited set already. So visited dot contains I is false. That means we could append the city to our visited set, and let's continue running DFS on this new city that's the neighbor. So I visited and is connected. Okay, so that is our helper DFS method, and now we're pretty much done with the question. So let's code up our algorithm for each city that we have. So city is less than is connected dot length city plus plus. If the city is not in our visited set, so if visited dot contains city equals false, then we have a valid province. And let's run DFS on this city. So visited and then is connected. Java is a little bit verbose, and then let's return our answer. Let's run this. Okay, then let's submit. All right, we see that it passes, and this is our solution. Thank you.